Application of Laplace transform in circuit analysis. So before going for this, we'll see the individual elements representation from time domain to S domain. So first we'll start with the resistor in S domain. So resistor in time domain, if you have simple resistor, the current I will flow. In time domain, the current is represented with I of t, small I or I of t, small v or V of t. Small v means voltage in time domain. Small I means current in time domain. Capital R is a resistor. The same thing can be represented in S domain. When it convert, I of t is converted into the I of S, capital I of S, or we can say that capital I. Here small I is nothing but I of t. Capital I is nothing but I of S in S domain. In a similar way, small v means in time domain V of t. Capital V means V of S. Like, how can we get this time domain element into the S domain? So if you consider the resistor like this, what is the, when you apply the Ohm's law, what is the voltage equation? V is equal to R into I. By applying the Laplace transform, like I said, small v will become capital V, or as usual small I will become capital I, or I can write V of S is equal to R into I of S in S domain when you are applying the Laplace transform to the time domain equation. It will become like R will become resistance. R units both in time domain and S domain, the same units like ohms only. But however, voltage V of t will be converted into the V of S, I of t will be converted into the I of S. The corresponding units of S domain voltage and S domain currents are volt seconds and amp seconds, because integral 0 to infinity f of t into dt will be there, right? That seconds will be added here in S domain, volt seconds and amp seconds. The resistance element does not change while going from the time domain to frequency domain. Resistance units also same. The next one is inductor. The next element is inductor in S domain. How do we get the inductor in S domain? If we see the inductor in time domain, inductor is represented with L. The voltage across inductor is small v, and the current is I. If it has some initial current, that initial current I am representing with capital I naught. Here this is constant. Okay. So consider an inductor shown in the figure with an initial value of the current I naught, capital I naught amperes. So by applying the Ohm's law, what is the voltage across inductor? V is equal to L into di by dt. V into d, L into d, V is equal to L into di by dt. If you apply the Laplace transform on both sides, small v will become capital V of S or capital V. Laplace transform of L into di by dt. We have seen during that operational transforms, Laplace transform of df of t by dt is equal to s into f of s minus f of 0, right? In a similar way, Laplace transform of L into di by dt is equal to L is constant, s into I of s, small I will become capital S into I of s minus I of 0. If I multiply with L, then it will become SL into I of s minus L into this I of 0. I of 0 I can rewrite it as I naught, as it is initial current, small initial current I naught. So V of s is equal to SL into I of s minus L into I naught. So this equation to satisfy the two circuits, the first consists of an impedance SL ohms. This is the SL ohms is multiplying with the corresponding current in series with an independent voltage source of L into I naught volt seconds. L into I naught I can represent with the, because voltage is sum of the two voltages. Here I have impedance, it is multiplying with the current, that will become the voltage, and this is an independent voltage of L into I naught. And I can rewrite the same equation like to find out the I of s. I of s is equal, this will go on the left side, V of s plus L into I naught by SL will go to the denominator. If I rewrite it again, V by capital V of S by SL, or V by SL plus I naught by S. This I naught I of S is equal to V by SL, means V by impedance. SL is nothing but impedance here. Voltage divided by impedance, and also one current source. I can represent the second equation and third equation pictorially like this. So what is the first equation? What is the second equation? V of S is equal to SL into I of S minus L into I naught, right? To represent this equation in the figure format or pictorial representation, small I became capital I or I of S. L became impedance like SL in S domain. SL is multiplying with the I of S. SL is multiplying with the I of S. And this is independent voltage source. As it is minus, I need to represent with the minus plus. Li naught is the magnitude of that independent voltage source. The same second equation can be represented like this. L become SL, and the independent voltage source can be represented with Li naught. So I become small I become capital I for the second equation. For the third equation, also pictorial representation, total current I of S is split into the individual currents. This I naught by S is nothing but current source. I can represent with the current source. And V by impedance. SL is nothing but impedance, voltage by impedance. Capital I means I of S is split into the, here the voltage across this parallel branch is V of S or V. So V by SL plus I naught by S, current source. This is what voltage across this parallel branch. So if you see here, the second S domain equivalent circuit that satisfy the equation 3 consists of an impedance SL ohms in parallel with I naught by S as an independent current source. SL impedance is parallel with the independent current source. So this will use the same representation of the parallel circuit or series circuits used in the circuit analysis. Wherever you are having the single inductor like this, that can be represented in the series representation like this. Inductor SL, L will become in time domain to S domain like SL impedance in series with the Li naught independent voltage source. In a similar way, parallel representation means SL in parallel with the independent current source. The same circuits will use during the circuit analysis with the problems. If the initial energy stored in the inductor is 0, then I naught will become 0, right? Then the S domain equivalent circuit of the inductor reduces to only the inductor impedance, inductor with an impedance of SL ohms. If initial energy stored in the inductor is 0, means what is the initial energy stored in the inductor? Of Li square. If I naught becomes 0, then only the energy will become 0, because inductor will not become 0, only current have to become 0. Then when I naught becomes 0, then only the energy will become 0. If I naught is equal to 0, then energy becomes 0. If I naught is equal to 0, earlier we have here I naught by S in parallel representation. This I naught becomes 0 means it will be open circuit. Current is equal to 0 means this said it is open circuit. You have only SL impedance. You have only SL impedance. Even in the series representation also, L into I naught, right? When I naught is equal to 0, it will get short circuit. Only you are left with the SL impedance. That's what we have represented here. So this is all about the inductor representation. In a similar way, capacitor in S domain. If you see the capacitor in S domain, so the capacitor in time domain I, and capacitor current is small I is flowing through this. Actually, this is small I. Small I flow through the capacitor C, and the voltage across capacitance is V. Initial voltage across the capacitance is capital V naught. This is constant. If it converts into the S domain, the C will become 1 by SC. Like how your inductor in time domain L becomes SL when you are applying the Laplace transform. We have seen with the derivation, right? In a similar way, capacitance C will become 1 by SC. So if you consider an initially charged capacitor shown in the figure, that is with the V naught it has charged, the initial voltage on the capacitor is V naught volts. If you apply the Ohm's law, again I is equal to C into dV by dt. If you apply the Laplace transform to this time domain equation, capital I of S is equal to C into Laplace transform of differential. That is nothing but S into V of S minus V of 0. If you multiply with the C, Cs into V of S minus C into V of 0 can be represented with the V naught. The same equation I'll represent with the figure format. I of S is the total current. The parallel branch voltage is V of S. V of S into Cs, right? So here parallel branch admittance, V of S into what is the current across this branch means voltage into admittance, right? What is the admittance here? 1 by Cs. It is actually 1 by Cs. Voltage divided by, what is the resistance here? What is the impedance here? V of S by 1 by Cs. V of S by 1 by Cs means V of S by 1 by Cs means it will become into Cs, right? So that's why it is Cs into V of S minus CV naught is there. Minus CV naught means we have to represent the current source in opposite direction. CV naught I have represented. Just like in an inductor, I have done this current source. Total current is nothing but sum of these two currents. This can be the independent current source. And what about this one? Voltage divided by impedance means if it wants to Cs need to be multiplied in the numerator means it has to be V of S by 1 by Cs. Then only it will go to the numerator, right? That's why I have represented C capacitance with the 1 by Cs. In a similar way, from the same first equation, if I rewrite this equation to find out the voltage, V of S is equal to this CV naught will go on the other side, I of S plus CV naught by this C of S will go to the denominator. 1 by C of S, if I rewrite this equation, 1 by C of S into I of S plus V naught by S. Current is multiplying with the impedance. The corresponding impedance is 1 by Cs and I of S plus independent voltage source V naught by S. That is equal to total voltage. That's what the pictorial representation. If initial voltage is equal to 0, here also, if initial voltage is equal to 0 means V naught is equal to 0, this current source will become open circuit. You are left with the only 1 by Cs. If initial voltage is equal to 0, this will get short circuit. You are left with only 1 by Cs. This is all about the individual elements like a resistor, inductor and capacitors from time domain to S domain representation. Here resistor will become a resistor only, time domain to S domain. Inductor becomes Ls. Capacitance becomes 1 by Cs. Okay. Thank you all.